Good afternoon, dear children. In the previous class, we were doing problems from Bayes' theorem. So you can note down the question here. Let us continue the problems from exercise 13.3. Here is the question. A laboratory blood test is 99% effective in detecting a certain disease when it is in fact present. However, the test also yields a false positive result for 5% of the healthy persons tested. If 0.1% of the population actually has the disease, what is the probability that a person has the disease given that his test result is positive? So read the question well, find out what is E1 and E2. What are the partitions? You have to read the question well. See, we are dividing the population. We are considering a population and giving a test to them. So here, this population can be divided into two groups. First is has the disease and not having disease. And for both these groups, taking laboratory blood test. And here, this can be divided into when the test result can be positive or negative. And here also the test result can be positive and negative. When we consider a population, some people have the disease and the remaining are not having the disease. And when a laboratory blood test is done for them, the test result may be positive here or negative. For this group also the test result may be positive or negative. Now you have to identify what is E1 and what is E2. What is E1 and what is E2? Come on, give your answer. When we draw a diagram like this, the first part gives E1 and E2 here. Okay, you have to identify this. This is E1 and this is to be taken as E2. So E1 is people having disease and E2 people not having disease. Okay, so read the question and say the answer to this. Probability of E1, what is probability of E1 and what is probability of E2? What is the probability of E1? That is, people actually has disease. It is given in the question, you have to read it well. Read the question. If 0.1% of the population actually has the disease. See this sentence, if 0.1% of the population actually has the disease. So probability of people having disease is 0.1%. Okay, now what about this probability of E2? This is equal to 1 by 1000. I told you probability of E1 plus probability of E2 must be equal to 1. So if probability of E1 is 1 by 1000, what is probability of E2? That is people not having disease. Give your answer. What is probability of E2? Children, give your response. Give your answer now. See, probability of E1, that is people having disease, is 1 by 1000. So what is the probability of people not having disease? It is equal to, see, this is 1 by 1000, so we can write this as 999 divided by 1000. You have to give your response. It is 99.9 by 100, or you can write it as 999 by 1000. Okay, now what is A? What is the event A? What is the event A? You have to read this question. What is given here that is to be considered as A? It will be given here in the question as given that or found to be, like that. So what is the event A? The test result is positive. Okay, very good. The test result is positive. That is the event A. See, it is given here, given that his test result is positive. This is to be considered as the event A. Now we have to write the probability of test result is positive when people have the disease. Test result is positive when the people have the disease. Probability of A given E1. What is the probability here? Probability of A given E1. See the first sentence. A laboratory blood test is 99% effective in detecting a certain disease when it is in fact present. That means if a person is having the disease and if he gives the blood test, then his result will be positive. For 99% cases, if the person has a disease, the test result will be positive. So what is the probability of A given E1? It is 99 by 100. In 99% cases, if the person has the disease, the test result is positive. In 99% cases, it will be true. Then the second part is probability of A given E2. That is, A given E2 means the probability of the test result is positive when the person has no disease. The person is not having disease. Not having disease means the person is a healthy person. So what is the probability then? If the person is a healthy person, then the test result is positive. It is 0.5%, that is 0.5 divided by 100, or you can write this as 5 by 1000. Now what we have to find? What is the probability that a person has the disease? A person has the disease. A person has the disease means probability of, we have to find probability of E1 given A. This is equal to probability of E1 into probability of A given E1 by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. Apply the values and find out the answer. 1 by 1000 into, this can also be written as 990 by 1000 because all other denominators are 1000 here, so we can write this as 990 by 1000, then divided by 1 by 1000 into 990 by 1000 plus 9 by 1000 into 5 by 1000. Find out the answer. Is this clear? What's the final answer now? What's the final answer? You can write this as, denominators are same, so you can cancel them. It will become 990 divided by 990 divided by, here it is 990 plus 5. So you'll get it as 5985, right? (990) divided by 1000 into 1000. Here also the denominators are same, so it will get cancelled. Here numerator 990 plus 999 into 5. So it will become 5985, I think. Or you can simplify this as 22 by 133. Do you get the answer? Okay, now let us move to another question. I hope you had completed the calculations. Okay. Another one question. See, now there are 3 coins. One is a two-headed coin and another is a biased coin. That comes up head 75% of the time. And the third is an unbiased coin. One of the 3 coins is chosen at random and tossed. It shows head. See, one of the 3 coins is chosen at random and tossed, and it shows head. It shows head. What is the probability that it was the two-headed coin? It was the two-headed coin. So how many events make the partition here? Read the question well and say how many events make the partition. See, in the first question there are 2 bags. From one that we are choosing one bag and then selecting a ball. Then in the second question, out of the students of a college, there are hosteliers and day scholars. So two events make the partition of S. Then multiple choice test. The student knows the answer or he guesses. Again 2 events are there. So in the previous question, we are considering a population having disease and not having disease. Again 2 events are there. So here in this, how many events are there? So there are 3 events. 3 events, that means there are 3 coins. 3 coins. So the first coin, which is a two-headed coin. Two-headed coin, that is both the faces are heads. Then second one is a biased coin. It is a biased coin. And now the third one is an unbiased coin. So 3 cases are there. This is to be taken as E1, second one biased coin E2, and the third as E3. So you can write E1, E2 and E3. Coin is a two-headed coin. Then second one is a biased coin. And the third one is coin is unbiased. Since the first one is a two-headed coin, if we toss this in both cases, we will get head. It is a two-headed coin. That means both the faces are heads. And in the second case, head and tail are there, but comes up with head 75% of the time. That means when we toss this second coin, head comes up 75% of the time, that is 75 by 100. And the remaining 25 by 100 times the tail occurs. But here in this case, this is an unbiased coin, so getting head and tail are of equal probability, that is 1 by 2, 1 by 2 each. Here this becomes 3 by 4, so the remaining is 1 by 4 in this. Is this clear? Okay, so you can write probability of E1. So 3 coins are there. Out of these 3 coins, you have to select one. So what is the probability of the first one? Selecting a coin. Probability of E1. It is 1 by 3. Okay. Probability of E1 is 1 by 3. What is probability of E2? Probability of E2 and probability of E3. Each of these having probability 1 by 3. See, probability of E1, selecting the first coin is 1 by 3. Selecting second coin, its probability is also equal to 1 by 3. Selecting the third coin, the probability is equal to 1 by 3. Now you have to write the event A. What is the event A? Getting a head. Okay, very good. Getting a head. See, A is the event getting a head. Now we have to write probability of getting a head when the first coin is chosen. Probability of getting a head when the first coin is chosen. From here you can write the probability. See here, it is a sure event since both the faces are heads. Whichever face occurs in the toss, head occurs. It is sure, so its probability is 1. So what about the probability of getting a head when the second coin is chosen? It is given as 3 by 4. See, here it is given as 75% of the time head occurs. 75% means 75 by 100, which is equal to 3 by 4. So its probability of A given E2 is 3 by 4. Okay, it is 75 by 100, or you can write it as 3 by 4. Now what about the probability of A given, that is getting a head when the third coin is chosen. Probability of getting a head when the third coin is chosen. It is equal to 1 by 2. Okay, now what we have to find? What we have to find here? What is the probability that it was the two-headed coin? What is the probability that it was the two-headed coin? So what we have to find here? Probability of two-headed coin, E1 given A. Okay, we have to find probability of E1 given A. This is equal to probability of E1 into probability of A given E1 by applying Bayes theorem here. Denominator is the total probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 plus probability of E3 into probability of A given E3. Apply the values. All these values are known to us. Probability of E1 is 1 by 3. 1 by 3 into 1. 1 by 3 into 1 divided by 1 by 3 into 1 plus 1 by 3 into 3 by 4 plus 1 by 3 into 1 by 2. Simplify and find the answer. It is 4 by 9. Okay. 4 by 9. Did you get an idea how to find E1, E2, E3, etc. and to find the event A? Okay, then let us do one more question. Next one. You can copy the question from the textbook. Now you just read the question and say what are the partitions and their probabilities and all. So it's question number 7 from exercise 13.3. So just read the question. An insurance company insured 2,000 scooter drivers, 4,000 car drivers, and 6,000 truck drivers. The probability of an accident are 0.01, 0.03, and 0.15 respectively. One of the insured persons meets with an accident. What is the probability that he is a scooter driver? So you have to find out how many events make the partition, what are their probabilities, what is the event A, and what we have to find. So how many events make the partition here? Three events. So what is E1? Selecting a scooter driver. Then E2 is a car driver, and E3 truck driver. So you can write probability of E1, probability of E2, and probability of E3. What is probability of E1? Probability of being a scooter driver. It is equal to 1 by 6. That is number of scooter drivers 2,000, and the total number of people considered here is 2,000 plus 4,000 plus 6,000. It is 12,000. So probability of E1 is 1 by 6. What is the probability of E2? Probability of E2 is 4,000 by 12,000, which is equal to 1 by 3. And then probability of E3. Probability of E3, which is equal to 6,000 by 12,000, that equals 1 by 2. That's equal to 1 by 2. Now you have to identify the event A. What is the event A? Can read the question and give the answer to this. See, when you write A, don't not to be written it as the probability. Okay, just write an insured person met with an accident. Met with an accident. Okay. So this is A. Now we have to find probability of a person met with an accident when he is a scooter driver. It is 0.01, which is given in the question directly. The probability of an accident are 0.01, 0.03 and 0.15 respectively. So here probability of A given E2 is 0.03 and probability of A given E3 is 0.15. Now what we have to find? Probability of E1 given A. Okay. Probability of E1 given A is equal to, you can substitute the values, probability of E1 into probability of A given E1 divided by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 plus probability of E3 into probability of A given E3. Substitute the values and find out the answer. One by 6 into 0.01 divided by 1 by 6 into 0.01 plus 1 by 3 into 0.03 plus 1 by 2 into 0.15. Okay, the answer is 1 by 52. Right. It's 1 by 52. Okay, one more question now. One more question here. You can read it. A factory has two machines A and B. A factory has two machines A and B. Past record shows that machine A produced 60% of the items and machine B produced 40% of the items. Further, 2% of the items produced by machine A and 1% produced by machine B were defective. 2% of the items produced by machine A and 1% produced by machine B were defective. All items are put into one stockpile and then one item is chosen at random from this and is found to be defective. One item is chosen at random from this and is found to be defective. What is the probability that it was produced by machine B? How many events? Okay, two events. Which are they? Machine A and machine B. Produced by machine A. Items produced by machine A and produced by machine B. So what is probability of E1? E1 is 60 by 100. And what is probability of E2? It is 40 by 100. Now what is A? Item is defective. The item is defective. That is the event A. Now what is probability of item is defective when produced by machine A? Probability of a defective item when produced by machine A. It is 2 by 100. Okay. Then what about probability of a defective item produced by machine B? It's 1 by 100. Okay. Now what we have to find? We have to find probability of E2 given A. Probability of E2 given A. This is equal to probability of E2 into probability of A given E2 divided by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. Apply the values and find out the answer. Is equal to 1 by 4. I hope you got an idea about this base theorem. Try the remaining questions. That is 4 questions are left in exercise 13.3. You try it today itself. And if there is any doubt, please message me. I hope you enjoyed the class. Let us meet with another topic in the next class. Thank you for joining and have a nice day.